Previously, I did a video on the domain of functions, and today I want to do one on the range of functions. The range of a function is a set of values which the variable y can take on the y-axis. In this video, I'm going to show you how to state the range of a function in set notation. Let's look at the following graph. Remember that we are looking at the range of values on the y-axis. I highlighted the y-axis because this is where the range is. You'll see that the highest number on the y-axis is 3. The graph contains a filled-in circle, which means that this point is included. It also contains an arrow on the other side, and that means that the graph continues indefinitely in that direction. So we would say this represents the set of all y values such that y is less than or equal to 3. In set notation, we would write brackets, and then we would write y is such that y is less than or equal to 3. We finish off with a bracket. Now in this example, we have a graph which seems to be bounded by this dotted line underneath here. This is what we call the asymptote. The asymptote is a bit like a fence. It says you cannot go below that line over here. You can get very near that line, but you can never touch that line. And that line is called y is equal to minus 2. So the values of y cannot be minus 2. They can go very near minus 2, but they cannot be minus 2. The other arrow here shows us that these values can go into infinity. And so the meaning of this would be that it is a set of values where y is greater than minus 2, but not equal to minus 2. In set notation, we would start with a bracket and say y is such that, and we would say y is greater than minus 2. This graph contains an open circle, and an open circle means that this point is not included. So the point 1, which is on the y-axis over here, is not included. At the end of that graph line, there is a point over here with a filled-in circle, and this means that this point here is included, so 3 is going to be included. So the range of values will be from 1 to 3, but 1 is not going to be included, and therefore we will write this down, brackets, and y is such that, since the range of values start with minus 1, we can put minus 1 and 3 at the end, and x is between. So minus 1 is less than x, and x is less than or equal to 3. You need to be really careful with this one. When we were looking at the domains, we had this graph there too, and we had these two asymptotes. These asymptotes were relevant then when we were doing the domain, but they're completely irrelevant at the moment because they are not part of the range of y. But what is important is this dot over here, because this point over here signifies that this graph over here does not go beyond that point. That point seems to be minus 1. So we have a range of values that are equal to minus 1 and are less than minus 1. But then we have to go and have a look at these two graphs over here. And they have an arrow on both sides. That arrow here indicates that these values continue on and on and on and on and on, but they never touch this line. In fact, this line is considered to be the asymptote. So the asymptote is at y is equal to 0. So our points or our range cannot go below that point, but our range can keep on going up into this positive infinity. In this case, we'll need to put two statements, one for the upper part and one for the lower part. Let's do one for the upper part first. How would we actually say this? Y is such that y is greater than 0. So I can write y is greater than 0. It cannot equal to 0. You may find that sometimes some people might say y is such that 0 is less than y. It doesn't matter because the two inequalities are exactly the same. Now, for the bottom part, we would say that y is such that y is less than or equal to minus 1. Similarly, we could say that y is such that minus 1 is greater or equal to y. I guess my preference would be to use those two set notations. When we want to look at the range here, we are only interested in this asymptote, which is called y is equal to minus 1. Have this boundary or this fence which excludes them from touching that particular value minus 1. Apart from that, they could be anything. The values of y could go anywhere above that minus 1, and it can also follow anywhere below that minus 1. In fact, the only value that they cannot have is minus 1. In that case, all that's required for you is to say that brackets y is such that y cannot be equal to minus 1. That's all there is to it. In this graph, you notice that these arrows continue to the right and also to the negative direction, but they never touch that y equals to 0. That forms an asymptote. So we're going to call that y is equal to 0, an asymptote. And so our values of y will not go below that line, y is equal to 0. And our values of y also stop at this point over here, which is 2. And so the range will be seen between 0 and 2, but not touching 2. The set notation will be y is such that 0 is less than but not equal to x, which is less than or equal to 2. In our last graph, we note that the lowest point is going to be at this value over here, which is minus 3, and it includes the value of minus 3. And then the graph continues up to this maximum over here, and that doesn't stop, because though it comes down again, the values of y continue then to rise on and on into infinity. So our values of y will be everything from minus 3 and including minus 3 all the way up to infinity. This means that y has to be greater than minus 3. So we'll just write y is such that y is greater and equal to minus 3. If you haven't seen the first video on the domain of the functions, then I suggest that you do that before you actually look at this one. Please subscribe to my channel, it'll help me a lot, and like this. And I'm leaving a link to my domain of the functions.